Thank you so much, everyone. So as I mentioned, Jimmy Johnson from Chainstate is going to give us an introduction to Gossamer.
Okay, there we go. We can all see, we can hear, beautiful. Okay, what is up, everybody? I'm Jimmy Johnson. I'm a developer at Chainstate Systems. And I'm going to be talking about Gossamer, giving you a little overview of it, and showing some of the things we can do with our clients. So, yeah, let's get into it. Just to give you a little bit of an agenda of what we're going to be doing. First, I'm going to do an introduction into who Chainstate is and what Gossamer is. Breaking news is an alternative Polkadot client. So I'm going to get into, well, one, what that means to begin with, and then why I think it's important to have alternative clients in blockchain systems, and then why they're like hard to implement. So yeah, we're going to go over that. And then we're going to go over the kind of the timeline of what Gossamer's gone through, where we are currently, and then what we have in store for the future and what you guys can look forward to. And then I'm going to give a little demonstration using the substrate frontend UI to interact with the local Gossamer node, just to give you a little tease of what we can do. So a little introduction. So who's Chainstate? We're a multi-chain blockchain R&D company. We do all sorts of things. We have a bunch of engineers who do lots of cool work. We have a couple different client implementations. The first which I'm talking about is Polkadot. We have a Polkadot node that we're building out in Golang. We have an ETH consensus layer client. We have a Mina node and a FilePoint node. We also do a bunch of different tooling. So for those of you that have played around in the Ethereum ecosystem and done any dApp development, you probably know Web3.js. We're the main maintainers of that repository. We built out an implementation of Snorkel signatures in Golang, which we actually use in Gossamer because that's what we use in Polkadot. And we have a bunch of different products and services. We have a bridge, like our own bridging solution. We have decentralized storage. We have a gaming SDK built on the Unity gaming engine. We do like smart contract auditing. Pretty much if you need anything, we can probably do it. So hit us up if you need any R&D work done. So then, what is Gossamer? It is a Golang implementation of the Polkadot Host. And so what does that mean? So for those of you who don't know, Polkadot kind of runs where you have the runtime, right? And that's where all the logic of like staking and governance and all these kind of more high-level blockchain activities occur. And then you have the host, which the runtime kind of sits on top of. And that's where all the networking happens, all the consensus, all the like database interactions. All of this is built in, like Polkadot was designed in a way so that you can build a custom runtime without having to worry about everyone building out the consensus with them. So that's a really nice thing in Polkadot. And so we're building out the host in Golang. That was initially built by Parity in Rust. So now we're building it out in Golang so you can build blockchains in Go. And so we're helping Polkadot fulfill a multi-client vision, which we think is really important. And I'm going to get into why that is here in a little bit. We've been working since 2018 on this. This is our team right here. I love them, so I put their pictures up to give a little shout out. We're all over the world. We all get along. It's a fun time. Yeah. So that's Gossamer. And so now I'm going to talk a little bit about alternative clients. So first of all, what is an alternative client? And kind of to define what that is, you kind of have to understand what a blockchain is to begin with, right? Like, and so a blockchain is a protocol. It's a specification where you define the rules, and then those are the rules of the network, and that's what a blockchain is. So then you have to build it out, and then that's what it becomes. So like for Polkadot, there's a Polkadot specification that the Polkadot implementations adhere to. And currently, the only live implementation is built in Rust by the Parity team. But that doesn't mean that they're the only ones that can build it out. And so we're building an alternative client implementation because it's an alternative to the initial one built in Rust. We're building it in Go. And so why did we need to do that? Like it adds more complications to the network, and it's just like one, like it takes a long time. Like why is this even necessary? And there's a couple reasons that I think are really important, and I think like everyone else should too, so I'm going to talk about it. The first is that it distributes influence of the network like to more teams. So right now, all like protocol decisions and research and everything happens by a pretty small group of people and teams, which is fine to do like great work. But then like getting to collaborate with other teams and other people distributes the role and influence that they have in the network, and that can help make it like just better in the long run. It improves resilience for one. For those that were around in Paris, for the Shanghai attacks in Ethereum, there was a bug in the Geth client that there was a denial of service attack. And so while Geth was struggling, the parity client was able to keep producing blocks and help the liveness of the network. And so this really highlights that when you have multiple clients running in a network, a bug in one of them wouldn't cause like a catastrophic event over the whole network. You can kind of add to the security by having multiple nodes running. It makes the network more resilient, which is super important. And then it also supports growth, right? Like, so right now, if you want to be a protocol developer in the Polkadot ecosystem, you need to be a Rust developer. That has its pros and cons, whatever. Like Rust is great, but then also like that's kind of your only option right now. And so by we introduce Go, you can introduce whatever other language, Python, Java if you want. You open the doors to allow more people to come and work in the ecosystem, and you can have more tooling, you can have more developers in, and you just you basically lower the barriers to entry for participating in the network, which is, I think we would all agree that that's a really good goal to have, because we want people to come help build this out. And so then why are they hard? Well, the first very obvious answer is that blockchains in general are hard anyways, so building an alternative client doesn't make it any easier. It's still very hard to do. So then I wrote down a couple things that are just, that I think are hard about alternative clients specifically. One of them is, for those of you that follow Polkadot upgrades are aware of this, the spec is decently constantly changing. There's a lot of runtime upgrades, and we're following the initial implementation of the Polkadot specification, we're playing catch up to a moving target, so it's very dynamic. And we always have to be changing what we're doing, and which is great because like the blockchain's improving, but it's not easy to do. Another kind of interesting example is typing. So we need to be able to communicate with clients written in Rust, right? And the communication, how you communicate is based off of Rust types. So anyone that's written Rust knows there's like emails, for example. Golang doesn't have those, so, but we need to be able to receive messages from substrate and be able to interpret emails, even though that's not a language type that we have in our programming language. So we had to think about how to interpret Rust types in Golang, which is just kind of an interesting problem to have. And then we have to interface with a runtime written in a different language. Even once we're fully live, at least for now in the short term, runtimes will still be written in Rust compiled also. And so we have to interact with WebAssembly and Golang, and we need an interpreter to do that. And then other particularly interesting ones are networking and consensus stability. These are really finicky things anyways, and we have to be entirely aligned with the Polkadot implementations in existence, because like any form of consensus instability or like any slight deviant will just cause forks in the network, and then that's all sorts of bad stuff can happen, and consensus is really finicky, and so it's not super easy to be able to build it out and be compatible with other clients. But it also adds to the resilience. Like I said, when you do build it out and it works, then you have these multiple implementations all working together, which is really awesome. So now I'm going to talk a little bit more about Gossamer, like kind of the current state, because my intuition is not many people know where we are right now and what we've been up to, so I'm going to try and shine some light on that and then let everyone know what we have in store, because I think it's really exciting and I think the community should be excited about it too. So the current state, we recently completed our first audit. It's around consensus, which is a little bit important. So the main short-term problems that we've been working on are, one, responding to audit issues. We've gone through all of the high priority ones, but there's still a couple little ones that we need to figure out and fix. Supporting the latest runtime is probably our biggest task at the moment. There's been a lot of runtime changes. been following, and we're working on catching up to that. And then supporting parachains. We need to be able to support and run a relay chain node that can work and be compatible with parachains. And so these are our kind of short-term goals, and I'll get into more like what the future will hold after that. And then one of something we really value is developer friendliness, and that's going to be a constant theme about all of our development and our long-term goals. And this is stuff like, well, one, Golang has fast compile times, so that's really nice, and other stuff like ID compatibility is important. And so that's the type of thing we want to keep in mind as we're building out our client. So here's a little roadmap. So right now where we are is we're in the yellow, and then these other blocks are kind of like the next iterations of Gossamer. And so, like I just went over, what we're currently working on is supporting the latest runtime, finishing the consensus audit issues, and then we've been doing a refactor of our testing strategies and rewriting a bunch of our tests and making it more robust as we're beginning to think about going into production. It's really important to have a good and robust test suite. So we've been really improving our testing efforts, and then we've been doing memory improvements to make our node less memory intense. So that's all good stuff. Like I said, we're going to be focusing on user experience, and as we start to think about making it to West End. So for those who don't know, that's a Polkadot test network. And that's kind of our next target. We want to be live and validating and running nodes on the West End network. And so as we're preparing for that, user experience will be vital. From there, we are working on scheduling a networking audit to ensure our network is secure. And then we're going to release on West End. And that can happen with the audit because, well, it's a test network, so we're going to be responding to user feedback, fixing bugs, improving our client, and we'll sit on West End, improving our client, making the user experience better, making sure everything works. And then we're going to start development on Cumulus, parachain development. So for people that don't know, Cumulus is kind of like the glue that allows a parachain to talk to the relay chain. And it's really important. And so we're building out a version of it in Go so that you can run Gossamer as a parachain, use Go Cumulus, and then communicate with Gossamer as a relay chain node. And so you can kind of start to see that we're building out, like we're starting out as a relay chain node, and we're working our way to support parachains and like increase our functionality throughout the network. And so after we've been on West End for a while, we're confident in our client, we're feeling happy, people like it, then we're going to start thinking about moving to Gossamer and Polkadot, which is obviously the big goal. So like, not even the end game, but there's more goals after that. But the current big one is being able to run Polkadot validators and like running Gossamer on Polkadot and Gossamer. We think that that's our goal, and we think that'd be awesome. As we do that, we're going to be focusing on the community. Like, of course, we're open source, and we love contributors. We want people to be engaging with us. We want to get engaged with people. And as we start moving towards production, this will be something we really prioritize. And then from there, like once we're on Polkadot, then we want to go work with parachain teams. We want parachains to not only run like Polkadot and the parity client, we also want to be able to, we want them to run Gossamer and bring client diversity to the parachains as well. And we're talking really long-term goals. We'd love for WebAssembly to be able to support Golang compilation to WASM, and then you can have full stack Polkadot from runtime and host written in Golang. And that just how I was talking about reducing the barriers to entry in the system, we think that'd be an awesome thing. So this is kind of the Gossamer vision currently. I'm hyped about it. I hope you guys are hyped about it. And so now I'm going to give just a little demo running a single local node on my computer using the substrate front-end UI. So, and did I put the commands on a file? I totally did, so that I wouldn't forget. First, for anyone that's used Rust development, I'm going to let's go because my time's so fast. Cool. Yeah. Let's see. Do I remember how to do that? Anyone know the shortcut to Zoom analytics? I don't remember.
It's no worries, we can see.
Okay, cool. So yeah, compiled. So that's like a full blockchain node. It just compiled in a couple seconds, which I think is awesome. Let me copy and release so I don't mess it up. So what I'm doing right now is I'm initializing the Gossamer node. The node just got initialized. Now what I'm going to do, so I'm going to start the node. So what we see is us starting a local Gossamer node. I quite honestly do not want to spin up the network right here in front of you guys, so I'm going to run one node. But I can demonstrate the functionality it would work with if I spun up multiple nodes. And so you can see it started producing blocks. Just me and my local node running a local blockchain are just producing blocks. And so now what I'm going to do is I'm going to start this front end template. And so I'd like to, well, one, I'll explain what this is. So for those that haven't used it, this is a little UI that's kind of similar to Polkadot JS apps. It's just way more condensed. And I'd like to clarify that all the things I'm doing you can do through RPC calls, you can do through Polkadot JS UI, or Polkadot apps, sorry. This is, but I just chose this interface because I think it's like really evolved there and just easier to navigate and demonstrate. So right now we're connected to my local blockchain node, Gossamer. You can see we have a WebSocket connection. You can see we're running metadata 14. You can see that we're producing blocks and we're finalizing blocks after they're being produced, which is exactly what you want in blockchain. And then there's a couple of these test accounts, some of them come with balances. And then you have this other stuff you can do, right? You can do runtime upgrades if you want. This is where events will show up. They have this nice little UI for doing transfers. I'll start out demoing just a little bit of palette interactions. So let's start out with just like a little simple, let's see, what should we do? Let's get, actually no, let's try to do simpler. Let's go to system. And just, let's get the chain. To prove what chain I'm running right now, it's the Gossamer testnet, which is exactly what I'm running. What shows up here. So that's an RPC call that returns what chain I'm running. We can do the same thing with like, we'll get the name, we call it Gossamer, Gossamer. State. I'll get the metadata, so I'll get the current metadata on the chain. So we get all of this beautiful information, and I'm going to go through each thing right now. No, I'm just kidding. But you can see it's like we're in 14, matches with what's up here. Let's see what else we can keep. Let's see, what do we want? Let's do chain. Let's get the hash to the finalized head of the chain. We've been producing blocks and finalizing. Let's do it. Cool. And there you go. So now we've got the head of the finalized chain. So yeah, this is just exampling a couple of examples. I don't know if that's a word, but I'm demoing a couple of RPC calls. So now I'll finish up this little basic demo, but I'll do the transfers for you guys. So let's send some money from Alice to Bob. There are 2 test accounts. So I'm going to go over copy Bob's address. What is the 2? Let's send some money. Give a shot. And so now you can see this little status bar going on over here. And it'll tell you the status of the transaction. And now it's been included in the block. So you can see this event was submitted, the extrinsic was successful, the transfer took place. And we can go up here and notice that Alice has less money than Bob, and the transfer was successful. So that's basically what I have for you guys. Yeah, I'm open to questions if you have them. It's my little demo, so thank you.
So first of all, thank you for this effort. I want to say, just for a second, that I think a protocol is not real until people can write to it, right? So if you know, this is the first sort of attempt to make it real, so I want to give you guys some props here. Now, in terms of working with the protocol team, how do you guys, is there a forum? I'm not aware of a forum that works kind of at the protocol spec level. Like, how do you guys even follow the protocol? You just basically reverse engineer?
Well, so a little bit. So there's a specification that's made from the build by the Web3 W3 team. And so we have close working relationships with both the Web3 Foundation and Perry they have a readable specification that we are constantly reading. And we're, like, when they release changes, like, sometimes we communicate, and sometimes it's us going through the change logs on GitHub and seeing what they changed and figuring out. Because sometimes we get, we'll get a little uninformed on what's changed in the recent releases. So we have to go and figure out, like, oh, why did this break in our system now? What happened in the recent release? And then we have to go check that. And then, so did that kind of answer your question?
Yeah, so you actually have a team like Parity that actually works with you, or you can more that you just
not
work
a
on
direct
the
team
topic?
of Parity. We have a couple individuals at the Web3 Foundation that we have regular meetings with. And then we have communication channels open to people at Parity. I don't think it's a specific team, but like if we have questions, we go to them. They'll communicate things to us that they think we need to know. It's kind of just we have an open communication channel.
Thank you. And then I have a second question on the Gossamer, on the palettes. What do you guys use for a Go as an engine? And do you actually get the Rust palettes run fully? Is that
Also, what we use right now is Gossamer. That's the interpreter that we use, and yeah, we're able to interact with the palettes. And we've actually been exploring using a different interpreter because so right now it uses Seago. It's like they compile down to C, and then you can interact with the Gossamer. We'd like to not have Seago as a dependency just because it's kind of thick, and so we're working on not using it, but at the moment we use Seago for communicating with the Gossamer in the palettes. But yeah, that's something we can do currently right now.
That sounds good. Thank you.
Thank you.
Thank you so much, Jamie. That was absolutely fantastic.